Students, we are expected to evaluate integral 0 to infinity x to the power n divided by n raised to the power x times dx. I would be using n is equal to e raised to the power log n to the base e. I would be applying this. Now log e and e, they get cancelled, giving us n. So there is no impact of using n to be as log n to the base e raised to the power. So by using this, you are not making any changes at all, because e raised to the power log n to the base e is nothing but n. I'm just using the natural logarithmic expansion. So what I'm going to do is I'm going to be substituting n is equal to e raised to the power log n to the base e for n. So that would mean I can rewrite this as 0 to infinity x to the power n divided by e raised to the power log n to the base e raised to the power x times dx. Now this can be rewritten as e raised to the power log n to the base e raised to the power negative x integral 0 to infinity times x to the power n dx. Now I can further rewrite this as e raised to the power. What I'm going to do, both of quantities are exponents, so I can write this as x times log n to the base e with a negative sign times x to the power n times dx integral 0 to infinity. Now I would be using the substitution, let t be equal to x times log n. So from here dt will be equal to dx, this is a constant, log n, and when x is equal to 0, t will be equal to 0 times log n, which is equal to 0, and when x is equal to infinity, t will be equal to infinity times log n, which is equal to infinity. So using these two limits, we get 0 to infinity again, e raised to the power x times log n. This is going to be t with a negative sign, and in place of x you need to make the substitution. So this is going to be, from here I can rewrite this as t divided by log n is equal to x. So I would be substituting, in place of x I would be substituting t divided by log n raised to the power n times, in place of dx I need to substitute dt divided by log n. So this can be rewritten from here. This can be rewritten as dt divided by log n is equal to dx. So I can use this. So there's going to be dt divided by log n. I can rewrite this as e raised to the power negative t times t to the power n times dt divided by log n raised to the power n times log n integral 0 to infinity. Now these two things can be added or multiplied, and that would give me 1 divided by log n raised to the power n positive 1. Of course the limits are 0 to infinity, and e power minus t times t power n dt. Now we studied a formula. We know that integral 0 to infinity e power negative x times x to the power n times dx is equal to n factorial. We studied it at the beginning of this class. So I would be using that. So that would mean I would now have 1 divided by log n raised to the power n positive 1 times n factorial. Rewriting this, I get n factorial divided by log n raised to the power n positive 1, which is my final solution for this question.